Welcome to another video where we take a look at one of our workshops for Math 121. This time the data is what we call matched pairs data in statistics. And this is actually an example that we looked at back when we were doing correlation and linear regression. So we had this data set where we had the ages of men and women on the day when they got married. And when we looked at the scatter plot, we could see that there was a positive trend, right? Older men tend to marry older women, and you could even predict how much older. And now we're looking at this data and asking a different question. We're asking how much older are the husbands than their wives on average? In particular, is there a significant difference between the husband's age and the wife's ages? So this data, it looks like we have two different samples, right? We have the husbands and the wives, but in actuality, it's only one sample. It's a sample of couples. And then each couple has two different quantitative variables. The husband's age is one of the variables, the wife's age is the other variable. Those ages go together. This 25-year-old man married a 22-year-old woman. He didn't marry somebody else. So these two numbers are what we call matched pairs. And when you have matched pairs data and you want to see if there's a difference between the two variables, then you do one sample t-distribution techniques. So when you look at all the different formulas for the t-distribution, we've got these four different formulas that we've been looking at for the past 2 weeks. Matched pairs data looks like two sample data, but it actually isn't. It's one sample data where you use the one sample formulas. And then the one set of numbers that you're actually going to work with isn't the husband's age or the wife's age. It's actually the difference between the two. So here I've got the difference between this 25-year-old man and this 22-year-old woman is 3 years. And then the next couple was 25-year-old man married a 32-year-old woman. So the woman's older, and that difference shows up as a negative number. It just means that the difference between the husband's age minus the wife's age is less than 0, which means the wife is older. Okay, and so on. So every couple has a different difference. We have a whole column of numbers of differences, and we want to know what is the average in our sample of all the differences, and is that a big enough average that would make us start to doubt this null hypothesis, that there's no difference in the population between the average age of a husband and the average age of his wife. Okay, so I've summarized the data down here. I've got the sample mean, the sample standard deviation, and the sample size for the husbands, for the wives, and for the difference. And the only one of these that actually matters for doing matched pairs testing is the difference. We're going to do one sample testing with these differences. So the first question is to do a t-test to see if husbands are significantly older than their wives. So to do a t-test, you make your hypotheses, and these are already here. These are the hypotheses for the t-tests. The null is that there's no difference. So in other words, the null is basically saying that in the population, if you could get your hands on every married couple in the country, then there would be no difference between the wife's age and the husband's age. So the average of all the differences should have come out to be 0. And that's not what happened in our sample. So maybe our sample is telling us that that's not true, that the null hypothesis is wrong and we should reject it. So let's find out. We're going to do the t-test. We're going to use the formula. Here is the formula for a t-test. It's the one sample t-value formula, and we're just going to put our numbers into the formula. The number we're going to put in for the x-bar is the average difference. We had a 1.88 year average difference where, on average, in our sample, husbands were 1.88 years older. The mu naught, that's coming from the null hypothesis. And the null hypothesis, this is a little different, right? Because now we're doing this match pairs data. We had a null hypothesis that looked like a 2-sample t-test null hypothesis. And so it's saying that there's no difference between the husbands and the wives. Well, if there's no difference between the husband and wives, then what should be the true population mean of the difference? Well, it shouldn't be 1.88. If there's no difference, the mean of the differences should have been 0, and so that's the number that we're going to use for our null hypothesis number. Okay, the standard deviation, we have that. You just take, the column of all the differences, ask Excel what the standard deviation is. I did that, and I got 4.81, so I'll put that in here, 4.81, and then finally the sample size. Well, there were 24 couples. That's my sample size. Hit enter. There's the t-value, 1.9148. And once you have your t-value, you can just copy this into the app and see what the corresponding p-value is. So we can go to the t-distribution app. If we have 24 different couples, then we have 23 degrees of freedom. The t-value is the x, so I paste that where the x goes. And then remember my hypotheses here. Let me pull those back up. The hypotheses are, if it's going to go one way, we kind of know, just from just knowing a little bit about our culture and the way things work in the world, that if it's going to tilt one way, I bet it's husbands on average who are older than wives. So I think we can do a one-sided t-test here. And so when I make my when I do my t-value, the tail of the t-distribution that I care about is just the right tail. And so that's going to be the p-value. The part of the t-distribution that is as extreme or more than this t-value that we got would be this little tail of the distribution. So that's our p-value, and it looks like 3.4%. So if you're writing this on a test or something, what you should tell me what your t-value was. All right, so your t-value was 1.9148 or whatever. And then you should tell me what the p-value is. And the p-value is what the app told us. And so going over here to the app said it was 3.4%. 3.4%. Don't really need to be more accurate than that. And now let's explain what it means. So this is the main thing you need to know. Anytime you do a hypothesis test, you calculate a t-value, you find the p-value, and then you got to interpret it. And p-values are a little weird because it's the lower p-values that are strong evidence, right? And so is this low enough to count as significant? And the answer is yeah, it's just barely, right? It's just below 5%. So it is slightly significant, not super significant, right? It's only what I would call moderate significance. So you could say this is moderate evidence that we can reject the null hypothesis, that we should reject the null hypothesis. And what does that mean? Well, if we reject this, we're saying that actually there is a difference between husbands and wives. On average, husbands are older. So let's say that. On average, husbands are older than wives in the population, right? That's hypothesis testing is always about the population of interest. In this case, I guess this is a sample, and hopefully the sample is representative of the population of all couples in the United States. Now, of course, we should also think about the assumptions, right? Is this data really a random sample? And the answer is no, actually it wasn't randomly selected from the whole country. So that could possibly be a source of bias. So that's a concern. You should probably mention that. And then the other question is this data normally distributed, and or is it a big enough sample size that you don't need to worry too much about that? So think about that for a second. Is this a big enough sample size that we don't need to worry about normality? Well, how do you tell? Well, the rule of thumb we use is if the sample size is over 30, then it's big enough. And in this case, the sample size is only 24. There's only 24 couples. So we really should look more carefully at the data. I would recommend making a box and whisker plot or a histogram to see if the data looks roughly normal. If it is, then you're good. If it's skewed, then you really shouldn't trust these numbers that we just calculated. And you should say that. You should say, hey, I did a t-test, but I'm not sure it's right. Okay. All right, I'm going to skip that. You can take a look at that if you want to. Now, finally, last bit. It says make a 90% confidence interval for the average age difference between husbands and wives. Well, we know what the average difference was in the sample. It was 1.8, and so that's going to basically be the starting point of our confidence interval. We're going to have 1.88, and then it's going to be either plus or minus, and then we have the rest of the formula, right? T star times S over the square root of n. And that's a formula we can actually just use the this calculator here to do that for us. So let me pull up the numbers. First of all, the number 1.88 is the right x bar because we're looking at the average difference, and that came right from this chart. And then I've got my t star. I've got to look that up. I've got the standard deviation 4.81 and the sample size 24. So I've already got those entered. So t star, where is that coming from? That's coming from the t-distribution table. It's from this table. We picked the confidence level we're looking for. In this case, I'm looking for 90 degrees of freedom, so the third column. And then I go down until I get 90% confidence. And then I go down to however many degrees of freedom that I want. I want 23 degrees of freedom, sample size -1, right? And so this number right here, that's the right t star. I'll copy that and paste it into the app, and not that one, this one, and put it in for the t star. Hit enter, and there we go. We get 1.88 plus or minus about 1.68. So plus or minus 1.68. And then I just basically just have to add and subtract these two numbers. So if I add them together, that's a quick calculator problem. So let me pull up my calculator here. So Office Tools and Calculator. Oh no, Calculator's under Accessories on my computer. So Calculator, and let's see. So I've got 1.88 plus 1.68 equals 3.56. So what we can say is we are 90% sure that the average, and the thing we're trying to estimate here is the average age difference, right? So the average age difference between husbands and their wives is between, if I subtract, I can actually do that in my head because 1.88 and 1.68, they kind of look the same. It's just the 6 and 8 are different. So it's between 0.20 and then on the calculator, when I added them together, I got 3.56. And then what are the units here? Well, this is age. Age, of course, is measured in years. So years different, right? So we're 90% confident that we're between these two numbers. In particular, because these are all positive numbers, that means, remember, the husband is older than the wife. Okay. In fact, I probably should include that in my answer here. So maybe 90% sure that on average husbands, that would probably be a better way to say that, that on average husbands are between that number and that number of years older than their wives. That's it. Okay. Now remember, this is just talking about the average, right? The confidence interval is a net that's supposed to catch the average difference. It's not supposed to catch the individual differences. You can't say anything like 90% of husbands are this many years older than their wives, because that's nonsense. In fact, you just look at the data. Lots of the husbands are more than 3.5 years older than their wives, and lots of the time the wives are older than the husbands. There's a whole bunch of situations where that happens too. You probably know lots of people like that. So it's not that 90% of people fall in the confidence interval. It's that we're 90% sure that the parameter of interest. And what is the parameter of interest? Well, it's a population mean. So it's one of these mu's. And which mu is it? It's the mu that goes with the difference. It's the population mean age difference between husbands and wives. Okay. So this is just something to watch out for. It's not really a new technique. You're just doing standard one sample t distribution techniques. It's just these situations where you have matched data that kind of look like two sample situations, and you just have to realize, because the data came in matched pairs, that you actually just look at the difference, and then you only do a one sample t technique, either a confidence interval or a hypothesis test, or both like we did here. Okay, as always, if you have any questions, let me know.